You know, up there in that quiet, black expanse above our heads, we've got a problem. A really big one. And the scary part is, you can't even see it. It's growing every single day, and we are flirting with disaster. We're talking about space junk. So let's get into it. First, I just want you to look at this number, 131 million. That's the estimated number of debris pieces, 1 millimeter and larger, that are currently orbiting the Earth right now. I mean, that's just a mind-boggling figure. But what does a number that big even mean in the real world?
Okay, let's try to wrap our heads around this. Picture taking 131 million cars and just scattering them across every single city, every town, every village on this planet. That's the kind of density, the sheer amount of stuff we're dealing with up there.
So here's what we're going to cover. First, we'll take a tour of Earth's invisible junkyard. Then we'll talk about why this stuff is such a high-speed threat. After that, we'll get into the dreaded Kessler syndrome. Then we'll look at some wild ideas for cleaning up the cosmos. And finally, what this all means for our future in orbit. All right, let's jump right in. Section 1, Earth's invisible junkyard. Let's really get a feel for how crowded it's gotten. Just look at this. We have about 10,000 active satellites doing all the amazing things we rely on: GPS, weather, communications. But look at how they're just completely dwarfed by the junk. Over 131 million pieces of debris. Our working technology, the stuff we actually need, is just a tiny little speck in this massive orbiting garbage dump. And when we say junk, what are we even talking about? Well, it's a bit of everything. You've got these huge bus-sized rocket stages that were just abandoned after a launch. You've got thousands of dead satellites. Then there's all the shrapnel from things that have already blown up or crashed into each other, even tools dropped by astronauts, and yeah, even something as small as a fleck of paint. And that little paint fleck brings us to our next point. This is a high-speed threat. Because you see, in space, it's not about how big the junk is. It's about how fast it's moving. Up in orbit, speed is literally everything. Things aren't just floating around. They are screaming through space at up to 15 kilometers a second. That's almost 34,000 miles per hour. And at those insane speeds, even the tiniest little object packs an unbelievable punch. So check this out. An object that weighs just 50 grams, that's about the weight of a tennis ball, if that hits something at orbital speeds, it carries the same destructive energy as a kilogram of TNT exploding. A tennis ball hitting like a bomb. Just let that sink in. And this isn't just a theory. This stuff has actually happened. There's a story from an old Air Force space projects vet. A tiny fleck of paint, smaller than half an inch across, hit a space shuttle window. It didn't just crack it. It blasted clean through the first of 3 layers and took a huge chunk out of the second. At those speeds, you don't even see it coming. And this constant threat, this hailstorm of tiny cannonballs, leads us to the real nightmare scenario, a terrifying idea called the Kessler syndrome, the point of no return. Okay, so what is it? Well, it was first described way back in 1978 by a NASA scientist named Donald Kessler. And basically, it's a domino effect in space. The idea is that once we get enough junk up there, a single collision will create thousands of new pieces of junk. And those pieces will cause more collisions, which create even more junk, on and on until low Earth orbit becomes a lethal, impassable shell of shrapnel. And if you look at this timeline, you can see how this theoretical problem has become dangerously real. After Kessler's warning, we had these huge anti-satellite weapons tests that deliberately created thousands and thousands of new fragments. And then in 2009, it happened, the first accidental crash between 2 whole satellites. That one event created a massive new cloud of debris. We're actively making the problem worse. But here's the part that should really worry you. Back in 2009, Kessler himself said that according to the models, the debris field might already be unstable. That means even if we stopped launching everything today, right now, the chain reaction has already started. The number of collisions will just keep growing on its own. We may have already crossed that tipping point. So if the problem is already running away from us, what on earth can we do? Well, that brings us to our next section, cleaning up the cosmos. And believe it or not, the answer might just be lasers. I mean, think about the challenge here. How do you clean up millions of tiny objects moving faster than a bullet? It's like trying to find millions of needles in a haystack the size of a planet. Old ideas like nets and harpoons, they just can't handle this skill. So scientists are thinking way outside the box, and one of the most promising, if not totally sci-fi ideas, is a network of powerful lasers based in space. Now, how would this even work? It's not about blowing the junk up. That would just make more junk. No, this is way smarter. The laser fires these high-energy pulses that zap the surface of a piece of debris. This instantly vaporizes a tiny layer of it. That's a process called ablation. And that little puff of vapor acts like a tiny rocket thruster, pushing the object and slowing it down just a little bit. The whole process is actually pretty genius. You detect and track a piece of debris. You fire the laser. That little puff of vapor slows it down. That slight change in speed is enough to nudge it into a lower orbit. And once it's low enough, Earth's own atmosphere grabs it and pulls it down to burn up completely. Brilliant, right? So, does it actually work? Oh, yeah. Research shows the effect is stunning. Take a look at these numbers. A piece of junk at 900 kilometers up would normally stay there for almost 128 years. Hit it with the laser once, and that drops to less than 18 years. At 700 kilometers, you go from over 11 years to just a year and a half. This is a total game changer. Which brings us to our final and most important section, our future in orbit. Why does any of this matter? What are we really risking here? Well, the thing is, this problem is about to get a whole lot worse. We have about 13,000 satellites up there today, but with new mega constellations being launched, we're about to add tens of thousands more. More satellites means more traffic, a much higher chance of collisions, and a much bigger risk of kicking off that catastrophic cascade. And the ultimate risk here isn't just about losing some expensive satellites. The ultimate risk is that we lose access to space, period. A full-blown Kessler syndrome could create a permanent barrier of debris that would make launching anything impossible. We could literally trap ourselves on this planet for generations to come. Which leaves us with one last, kind of wild thought. You know the Fermi paradox? The question of where are all the aliens? Well, some have wondered if this is the answer. Maybe every civilization that reaches for the stars eventually trashes its own orbit, creating a great filter that traps them on their homeworld. The question for us is, are we going to be smart enough to break that pattern?